My name's Andrew Westgarth. I'm a program manager on Azure App Service. And my principal responsibility is for bringing our service to on-premise hybrid cloud environments. So be that with the product that we previously worked on up until we entered extended support this summer, Windows Azure Pack websites, now Azure App Service on Azure Stack, and another product that we launched to build, the Azure Functions runtime preview. So those are all inside my remit, and that's what I'm responsible for. So the details of our team blog are on the screen. It gets into some really deep dive technical implementation details about how we do things and how we think. My Twitter account's there and my email address. Feel free to get in touch. Twitter's often the fastest way to get a quick answer because what you can get into 140 characters normally makes it easy to answer. Although I did hear some spurious rumor that they want to change that to 280 characters yesterday. Really? Is there not something more important that you should be doing? But there we go. I'll leave it there. Email, yep, feel free to reach out to me. Very welcome. So my background, I've been with the Azure App Service team for about 3 years now. And prior to that, I was an IIS MVP for 8 years. So I've been around .NET development, web development, that kind of environment for quite some time. I was a technical architect at a FTSE 100 company in the UK where we launched an ERP system in the cloud. So used to operating at large scale. And then I joined the App Service team, which is a fantastic and fun team to work on. Today, this is very much targeted at the Azure Stack Cloud Operator. That's the level of this session. If you're here with a development background and you just want to understand the platform, awesome, because you're on the same wavelength as I am. I'm a developer by trade, but I've always had the opinion that if I understand what I'm actually building on top of, I can really exploit it, and that's very valuable. So today we're going to give you a brief overview of what Azure App Service is. We'll go through some core concepts and what the difference is between Azure App Service and Azure App Service on Azure Stack, what the delta is. We're going to have a look at the architecture and some admin scenarios. If you've seen this session at previous events, this has evolved as the products evolved. So there's more information in here. I will cover some ground that you may have already seen covered, but hopefully what you see today is very valuable as we get ever closer to that GA date. As we ever get closer to that GA release, then this stuff becomes more and more important. And as you're now in the waiting game, waiting for your integrated solutions arriving, some of you, then this is ever more important. And then I hope to have a good chunk for Q&A. If we don't get too much detail there, I am on the Azure Stack booth this afternoon. I'm on the Azure Stack booth tomorrow as well, down in the expo hall. And if I'm not there, I can normally be found either in between that, the App Service, and the Azure Functions booth, or certainly around the event. I'm certainly here all week. So what scenarios are we going to cover from an administrator point of view? We're going to cover deployment. We're going to go deep into deployment because a lot's changed. I'm going to show you a version that is not publicly available. So this is the version that we're actively working on getting ready to release to you. So it's the precursor to get you ready for production. So as we've gone through the technical preview and the release candidate process, we've gradually inched towards the actual release product. And now we're getting to the point where I've got, as you see on the list, I've got capacity guidance, capacity planning guidance, requirements that you need for the service to be up and running. What does the Azure Functions piece bring to the table? What do I need to think about? And then we talk about high availability and billing and metering. So hands up in the room, how many of you have attended either lots of sessions on Azure Stack this week, deployed the Azure Stack POC, ordered an Azure Stack, or know what Azure Stack is? Right, okay, so I'm probably going to graft over these slides really quickly, because if you're not familiar with Azure Stack, the main goal is that it's an extension of Azure, but within inside your environment, your data center, your colo, whichever place you wish to deploy it. And it's all about the consistency story. It's about having a consistent platform, consistent APIs, consistency throughout the tooling, consistency throughout the experience. So it doesn't matter. You should, to all intents and purposes, Be able to forget which portal you're in. Be able to forget what you're targeting, because it should be consistent along the way, and it's just a location. That's certainly the way that we look at it as a team. And as a team, when we bring features into Azure App Service on Azure Stack, the first bar it must check after being functional is it consistent with the way that we do it in Azure? Does it operate to tenants exactly the same that it does in Azure? If it doesn't, go back, fix it, and bring it back again. If that doesn't happen, then we don't bring it. We add some extra capabilities for Azure Stack, but we don't decrease the experience that you have in Azure. So Azure Stack first is a hybrid cloud platform. It is not a virtualization replacement play. That is pretty evident by the fact that we're bringing services like Azure App Service, Azure Functions, and any other services that we bring from Azure. It's an integrated system. It's not DIY infrastructure. The POC is DIY. The integrated system is not, for a variety of reasons. When I first heard that that was a decision that we'd made, I was surprised. I'll be open and honest, and that's my personal opinion. But having understood the reasons behind it, I now get it. I understand what we do inside our data centers. I understand that we have white lists of equipment so that we can replace quickly when something fails. And we need to have that same experience from an OEM standpoint so that when you have an issue out there in your enterprise, you know you can get that part replaced. You know you can get it done according to the SLA that you have with your OEM. Regular updates. So yes, this is a key thing. So Azure App Service will update on a regular basis. On top of the Azure Stack updates that you will get, I think it's on a monthly basis, you will get updates to firmware drivers, base fabric updates, etc. And then we will have our own update schedule as well. Today, we're not integrated in the patch and update story for Azure Stack, because the focus there is making sure that the Azure Stack appliance, the compute, the network, the storage, the key vault providers can all be updated through that patch and update routine. We have been in market with a product for close to 5 years. With our Azure Pack product, we have an update procedure that we know works, and we are confident that will work as well, and we will bring that to the Azure Stack product. That will be our initial play in updates. You will get a new drop, a new installer, and we will roll out the update in the same mechanism that we do updates already. It's a battle-tested method, and we are confident that it will work in Azure Stack. We've got a little bit of work to do, but when we get to update 1, we'll be in a good position. In time, we hope to meld it in with the integrated solution so that when an update to App Service appears, you just get a notification, you run a patch and update process. But we are not there today. And cross-platform. So key point here, one of the things that we launched in Azure App Service was Linux container support for applications. That is not available in the proof of concepts for Azure App Service on Azure Stack, and it will take us some time to bring it to Azure Stack, but it will come. I just don't have any dates to share with it. And this also speaks to our methodology of bringing services to Azure Stack. If they are battle-tested in Azure at high scale, then we can bring them down. Until such a point that they are battle-tested and proven, and we are confident that it will not create support headaches for you guys, we will not bring something down. So that will come, but not immediately. Believe it or not, I got emails hours before our announcement was made internally asking for that feature and whether it was already available. I'd love to do so, but equally, if we ended up with a major issue, it's then passing it on to you guys. We don't want that. We want to be able to know that when we give it to you, it's supportable, it's reliable, it's rock solid before you get it at lower scale. So the Azure Stack promise, just to finish this off, is a consistent app development platform. That's very, very important for our platform. We are the developer story, the pro developer story on Azure, and that's what our group is called, Pro Developer. And it's about bringing those services in a consistent way with an integrated experience. And I think this, if I only ever show one slide about Azure Stack, I love this one, because I think this really pops the message. So we have data centers all over the world, and we're growing that, and we're adding more. There's probably dots not on that slide that we've already got data centers in. But then if you add in the service providers around the globe, we all use them, we all daily use them. If they were to adopt Azure Stack, we've got a bit more coverage. And then thousands of enterprises around the globe. You know, I've worked for them, you all work for them. To bring that capability and that development story, the ability to be able to transfer skills, go out to the labor market and get more people in that have got those skills, you haven't got to retrain. All you have to focus on is a different location of deployment, nothing else. So App Service. When we talk about App Service, we look at it this way. We look at if you are hosting an application and you were comparing it to car ownership. So let's say your app is a car. So in IaaS, you can own and operate your own car, do all the maintenance, do all the upgrades, the modifications, you know, pay for the depreciation of that asset, deal with replacing it every so often, etc., etc. You could go down the SaaS route, which is you can take a taxi or an Uber or a Lyft. You pay a premium for using that service because you don't own the vehicle, you don't operate it, you don't maintain it, etc. Or you can go down the PaaS route, where effectively you're renting a car. So you're renting some infrastructure that somebody else maintains, somebody else updates, and somebody else. In this case, we provide the technology solution, but as cloud operators, you are the guys and gals running the PaaS service. You are effectively you are the rental company. So Azure App Service offers web app hosting, mobile app hosting, Azure Functions, which is our new serverless offering, and this is all coming to Azure Stack. API app support as well. And to give you an idea of the scale that we actually run at, we are operating 475,000 active customers, dealing with 15 billion requests on our platform globally every single day. And we're growing at a nice, healthy rate. The reason why I think this slide is valuable to the audience in the room is just to give you that confidence that the code that you're getting, the service that you're getting is the same thing that we're running in Azure, and this is the level of stress that we're putting on it. And this will grow. We're not at a limit of a ceiling or anything like that. We can deal with more scale. So this gives you the confidence to know that whether you're at small scale or whether you're at large scale, when you bring this into your Azure Stack environment, into your data center, your companies, you know that there's something out there that has actually been battle tested. An example of some of the customers that we have running, so we have Jet, an online store, and they have their e-commerce solution all running on, I think it's Node.js last time I checked, running on top of App Service at high scale. They're getting value. And then we've got the likes of Real Madrid, football team in Spain, and they are running their digital experience, so their fan connection for their global audience. So App Service has a huge number of user features and capabilities that you will be able to offer to your tenants. Tenants, users, I'll probably skirt around both of those terms, the same thing. And at times, there will be, full disclosure, there will be features that will take us longer to come down because we build on a fabric. So in Azure, we have capabilities to hook into other services that give us the ability to do things. In Azure Stack, we will need to wait for some services to come online before we can take advantage of them. And we'll cover some of those today, and then there's others that I can highlight. And you can help me to help you when we hit these. Because if you then go to those teams, those Azure teams, and say, we must have X on Azure Stack so we can do Y, then that gives them an actual use case and information about a customer that has a genuine use for something coming down. So some of the key things that I want to call out here is that we have, for tenants, scheduled backup, AD integration, we have web jobs, the precursor to Azure Functions, we have support for built-in load balancing, we have an app gallery which we're working on bringing to Azure Stack, custom domain support, wildcard support, CI/CD pipelines, integration directly with their dev tools. So if you're looking at providing a consistent platform from an IT perspective where you can code everything as infrastructure as code, so ARM templates, we're consistent in that manner, but then your devs can take advantage of the same thing from the other side. Azure Functions is our serverless offering, and this is a fast development model to enable teams and developers and even IT admins to get fantastic benefit out of using a serverless concept. It's all event-driven, so when events are triggered, then functions execute. They're exposed over HTTP endpoints. Some of the use cases that I heard last year when I was on the booth in Atlanta were for guys who were wanting to automate PowerShell scripts, automate creation of accounts and things like that, set up SharePoint sites, etc., etc. So you've got a wide breadth of what we can do with that. We can do everything from cognitive APIs, where we take in images and we do some sentiment analysis and that sort of thing, right down to just general, let's automate some very simple processes. They're very quick to get up and running with, very quick to deploy, and can run at extreme scale. Now this slide is our figures just for functions. So we've got over 30,000 active customers, and we've been in market coming up close to a year for GA. We're dealing with over 100,000 functions apps, and they vary in size from very small to very large to very complex. You can deploy APIs, microservices, etc. And we're dealing with over 1 billion executions a day. So this will become important when we get to the actual usage billing and the considerations for functions. These values are from May of this year, and we see growth is calculated. Oh, I've had it twice. Apologies for that. So Azure App Service on Azure Stack. What's the delta? So initially, here is the delta that we have today. So in bold is all the capabilities that we have out of the box. I would say majority of this is in release candidate 1, which is publicly available for you to use with the public version of the Azure Stack developer kit. So we have scheduled backup, we have AAD integration with our Easy Auth capability. The key thing to call out there, that's not AAD for your Azure Stack. So it's not a case of we don't support the ADFS Azure Stack, we do. It's just more, this is the tenant-facing features that are valuable. RBAC, audit, client certs, WebSockets, compression. And we're adding features all the time to the Azure product, so more and more is coming that's just not listed on this slide. We are working closely with TFS, the Visual Studio team, to bring those capabilities as well, which is extremely valuable to enterprise customers. So core app service concepts that we really need to nail right now. So in app service, we build based on app service plans. And this is the way that you guys will be able to get usage information and bill for usage. So an app service plan is a container for applications. And every subscription can have multiple app service plans. So an app service plan is if you like, it's analogous to, if you choose a dedicated instance, it's a reservation of resource. So we have 3 modes out of the box that we ship with today. We ship with free and shared, which are true multi-tenant. So when a customer deploys their applications into a free or shared app service plan, their applications, albeit in a sandbox, are deployed next to other customers' applications. It's a true multi-tenant model. And so that's one thing to think about. In an app service plan where they're using a dedicated instance, such as an S1, S2, S3, they actually find that their applications are deployed onto a dedicated instance that is only for them. So only for their applications allocated in that app service plan are deployed onto that instance. And that instance is the unit of scale. So by default, you can scale out to 10 instances. That's the maximum that a customer can use in an app service plan. We have ways in the public cloud of changing that, and you also have ways of doing that in Azure Stack. But that's an allocation of resource. And the way that an app service plan is metered, I'll come to this now, is a customer can deploy as many applications as they like into a single app service plan, so therefore getting full density of that individual instance or that series of instances. If there is an app service plan but it has no apps on it, it is still metered. because it's a reservation of resource out of the farm. So therefore, the meters will still tick. But the benefit to doing it this way, that the app service plan is a container for all apps, means that a customer can really take advantage and make full value of their investment. So if they pay, just for argument's sake, $10 a month for an S1, then they can get as many apps as they want to onto that instance, such a point that they exhaust the resources, and then they need to start thinking about whether they want to break those up, etc. But it means that they get full value out of their money. It's not a case of, oh, well, one app's going to cost me $10 a month. No, you can deploy as many as you like into there based on the constraints of the instance. We then have a concept called a worker tier, and a worker tier is a description for the web workers that host the applications in App Service. And in App Service on Azure Stack, you can customize those as operators. In Azure, you can't do that. We are operating the service. We tell you what you can do on our worker tiers and our SKUs. But in Azure Stack, it's your hardware, it's your environment, it's your investment. Off you go. We bill you the same. It doesn't matter what you've done on the underlying hood. So if, for argument's sake, say you ever got graphic GPU type SKUs in Azure Stack, we don't offer those in Azure App Service, but your business may have a distinct need to use that on-prem. Why should we stop you from doing that? You can then go and build a worker tier which uses those type of SKUs from CRP, from the compute resource provider, and then offer that to your users. And again, the worker tiers and the SKUs fits together. So the SKU, the stock control unit, or whichever way you want to talk about it, is a pricing structure, and it's fully customizable. So again, we ship with free shared S1, S2, and S3 out of the box so that we're consistent with Azure. But after that point, it's up to you to define what your offering is so that you can be different to us, you can be different to the next provider on the block. So, for example, some of our limits may be on number of slots that you can have at a certain tier, for example, for deployment slots. You may decide that for this department, I want to build a SKU that gives them this. For this department, I want to do it this way. Or for this customer, I want to offer this capability. So it's fully up to you, and we're going to go through and have a look at what that means. So the very, very high-level architecture of App Service. So we have a controller role. So the App Service controller is responsible for making sure that the cloud is up, running, and actively and healthy. It does all of our health checks, and it does the rollout of features across the board. And when you do an upgrade, the upgrade starts on the controller. The controller is the first thing that we upgrade, and then the controller pushes the upgrade out to the individual roles on a managed basis, so that we take. So when you're in a load balance scenario, for example, where you've got two management roles, we upgrade one first, wait for that to complete before we do the other one. So it's a managed process all the way through. So the controller, to a certain extent, is pretty dumb. It has one main role, and it sits there and monitors and makes sure everything's up and running and it's okay. So therefore, it doesn't need, when we come to capacity planning, it doesn't need to be the fastest hardware in the world, because for 90% of the time, it's not doing a great deal, it's doing basic work. The file server is on here because the file server and the database servers are critical to the scenario. However, the file server sits outside of the Azure App Service remit. We don't deploy that. So you'll see in a future build, we don't deploy this anymore, even on ASDK. You need to provide a file server for us to use. We provide you with a simple template for the ASDK, but we'll go into that in a bit more detail when we get to HA. The management server is today a principal operator in Azure App Service. This is where we host our API. All of our UI extensions for the tenant and the admin portals are all hosted on this endpoint, and we have what we call a data service. Now, the data service provides us a level of redundancy if, for whatever reason, we lose connectivity to the database. So if we lose connectivity to the database, we are in a situation where we cannot route requests, we cannot update configs, and we cannot maintain applications. However, in a situation where we do lose that connectivity, if requests have already gone through the system Our data service has got the information cached, so we know where to route requests to. So it gives us that level of resiliency. So if for any reason, transient errors or whatever, we lose momentary connection to the database, we have an ability to keep all of your tenant workloads up and running fine, no problem. Our front ends are our load balancers, so that's where we do our app service routing. Our publisher is our box where we do FTP. We also host web deploy on there, but we changed to make web deploy first-class citizen on the actual workers, so we deploy directly to web deploy on the workers. And the web workers themselves are the machines where the applications run. So that's where we have all of the application development stacks running. That's where we execute all of the workloads. And that is where you will see that you need the largest scale. So from a default deployment, this is what you will end up with. You will end up with a controller, a series of front ends, one or many publishers, one or many management servers. In a production environment, please don't deploy one, because you've got no resiliency. So we'll come to that in capacity planning, but it goes without saying, please do not deploy a single instance of any of these. Web workers is where you will spend most of your capacity. Web workers is where all the work is done, and that is how you will handle the load. On top of that, we have requirement for 2 SQL DBs, one for metering and one for hosting. So the metering database does what it says on the tin. It takes the information about what's actually being used within inside the application, enables us to provide you with usage counters, etc. for metering. Our hosting database is where all of our configuration is stored, where the configuration of the farm is, where the information about the workers, where sites are deployed, etc. So site creation flow. When a customer creates a site via the Azure Stack portal or via an ARM API, then an ARM request is made. The request is forwarded to our API, our resource provider API on the management role. The management role receives the request, and we create a site in the hosting database, and we create a content directory in the file server. No resource is allocated right now. Nothing has hit the workers at this point. Site content is published. Customer publishes direct to FTP. Publisher receives the connection. The FTP extension is then able to look up the home path from our database, and then the session is established and we upload the content to the site's home path. Again, no workers are currently involved in this process whatsoever. First request. Now this is important. When a customer makes a first request to the website, the front end receives that request. The front end then goes to the data service on the management role and says, have you the information that I need to tell me which worker I need to route this request to? If a data service says no, then it goes off to the hosting database and gets that information, stores it in the data service, and then sends it back to the front end. The front end then routes the traffic to the web workers, and the web workers serve the request back through the front ends, and that continues. Let's look at some admin scenarios and deployment. So our deployment has been very much an evolution. When we released the very first technical preview 1 with the very first preview of Azure Stack, we had a lot of PowerShell scripts that were prone to failure. So we learned from that, and with our previous experience with Azure Pack, we had an installer. So we've taken our installer and we've edited it and iterated through it, and we've done a lot of iterations in the last 6 months to make it even better, and we're always interested in feedback. So we have this integrated experience, and I'm going to dive straight into a demo to actually go through where we are currently. Let me just get rid of this window. Okay, so this is our installer. How many of you in the audience have deployed app service on a single node POC? Yeah, that's what I figured. Please don't take that the wrong way. That's no offense to anybody. I get the impression based on my telemetry that I see from installs that a lot of people have installed and then left it. And that, I'm just interested in seeing what people are actually doing. So out of those that have actually deployed App Service, how many of you actually got applications running and you've tested that far? Good, good, fantastic. So we deploy direct from the installer. We do have the capability to do a headless install, and we will probably publish those steps as a blog post on our team blog to do that, because we use that in our CI runs with Azure Stack. So they deploy App Service daily on their daily builds to validate that the whole process works end to end. So the first thing you'll get is a very short EULA based on previous experience of EULAs, and it's a supplemental to the Azure Stack license. Because we deploy on Azure Stack, we inherit their policies behind their license and then add our own as well. So it's a very short EULA. And then Azure App Service has a huge usage of open source components because of the breadth of applications that users want to deploy. So whether they're Node, whether they're Python, whether they're PHP, whether they want to use Git, Mercurial, Java, we need to bring these capabilities and install them onto workers. So there's a huge list of EULAs that you can read. You can do what most people do and just go, tick, yep, I read that. But seriously, we go through a lot of compliance to make sure that everything that we do is absolutely spot on before we release, so that the information is there for your benefit to make sure that you're comfortable with everything that is in there. Please make sure that you do review everything that we're installing. Because if for some reason in your compliance teams inside your organization, you do not want to allow something, this is the product. So please don't install something that you are verboten from doing so. We do some investigation. So when we launch the installer, we detect the endpoints from where you're deployed. And if you need to change these for any reason, you can manually edit them. But we've got to a stage where we're pretty spot on of being able to investigate all the endpoints from Azure Stack. You log in with your service admin account. And then we detect your subscription, your default provider subscription, and your local. And we deploy by default into a resource group we call App Service with the region. You can change this if you like to. That's no skin off our nose, to use a phrase. But we find it's consistent so that we can identify throughout the resource groups of what we are. Now, I've already deployed on this instance, but I want to show off the installer, so I'm just going to go through and change those. Here's the first thing. So the prerequisites for deploying Azure App Service with the next release will change considerably. There's a lot more to do in pre-work rather than doing post-deployment scripts that we've had in previous releases, because we've found that most people don't read past deploy. And then I get loads of forum posts, emails going, this doesn't work, this doesn't work, this doesn't work. And most of my stock answer is, did you complete the install? Yes. Did you do this bit? No. Okay, that's why that doesn't work. Go back and do that, and we fix it. So we decided, no, let's just get rid of this. Let's try and automate everything that we can and bring it forward. Plus, we're hitting production now, right? We want to produce an installer and a service that deploys on single node and multi-node. We don't want to have two, because that gives us support headaches and resource. You need to bring along with you a HA file server for any production deployment. So the reason we left this capability in is we know customers already have SANs. They already have NAS devices. They already have NetApp devices that they want to take use of. But in Azure Stack, they can't do it in the core solution, but we want to give you the option to bring that along as a migration strategy. You can equally deploy a HA file server cluster inside the default provider subscription for App Service. That is approved, and we are working on producing a sample template for you to do that. Today, the only one that exists that I know of is a scale-out file server, but it needs an AD connection, which you don't technically have in Azure Stack, so we can't use that template. So we're working on bringing another option. We will also have to support the development kit, the single node. We will have a simple template that produces a single node file server for you to be able to get up and run with as well, because we realize we don't want to make the bar to entry too high. So have I got one? Just trying to think if I've actually got one. I've just blown my demo up, I think. Okay. We may come back to the deployment if this takes a bit longer. Yes. I don't have it on this machine. We're too good at our own job. So I need a file server that I can use, and we validate whether we can use it or not. And I've already deployed. So, yeah, okay. So I'll walk us through the next steps. So the next steps are that we go through and we request the identity app information. So in the current release candidate, you are required to do the SSO steps, the single sign-on steps, for us to be able to use Kudu, be able to use the functions portal, to be able to scale out instances and all that sort of thing. And we create service principals to do that. This is an element that we found anecdotally and based on telemetry does not get done reliably or regularly and is not fought without errors. So now we have, in our helper scripts, we have a script to create that application, be that on ADFS or AAD, and you do that, and then you provide us with the app ID, the certificate that you use to create that SPN with, and the root cert for Azure Stack. Then we take that information, we validate, and we make sure that we can go through. This way, we can do all the configuration. You don't have a situation where it's like, oh, can you remote desktop onto the controller, run this command, copy and paste this value and all this. We do it for you. We don't need to do that anymore. Then we need to get to certificates. So certificates are important because we're now getting towards a production stamp. We still have the helper script for the ASDK so that you can provide self-signed certificates for this and still generate everything you need. But you need a wildcard for star.appservice.region.azure Stack domain. You need a wildcard for star.scm.appservice.region.azure Stack domain. You need a certificate for ftp.appservice, api.appservice, and you need a certificate for the SSO. So that's the certificate requirements. We advise to use one wildcard certificate with the 2 subject names for the wildcards, and then individual certificates for the others. It makes rotation easier. Whereas I know that there are customers that have asked for the ability to use one wildcard certificate for the whole of Azure Stack. And I'm like, yeah, if that's what you want to do, that's your customer requirements, we'll make sure we can support that. But our guidance for a long time has been use separate certificates, because then if for any reason you need to replace one of those certificates, when we come to certificate rotation, it's very easy. We then need SQL connection. So if you're deploying a production stamp, you need a HA SQL. Again, this does not have to be on Azure Stack stamp. If you've got a SQL cluster in your organization, because most of you have been around for a long time, you've got this kind of infrastructure, why not use it? As long as the throughput to your Azure Stack stamp is good enough, there's no reason why you can't use it. Question? Is
that SQL connection provided through the Azure Stack SQL RP?
No.
Does that have to be set up? Just a connection string?
So we don't, so the question was, is the connection to SQL done through the SQL adapter RP? No, it's not. All we need is a connection string. It's the same as the file server. The file server, all we need is a UNC file share and ACLs. And we've got documentation on making sure that the ACLs are correct. And there we go. Another question.
Can you use the RP? Isn't that another vector for chargeback, showback? Is that another resource that's consumed that should be accounted for?
In theory, you potentially could use the RP, but I'm hazy on where the actual SQL hosting servers are deployed, because I've seen a mixed conversation internally as to whether they're deployed in the tenant subscription or whether they're deployed in the provider subscription. So I'm caveating that with, we don't do that today. The other reason why we don't do it through the SQL DB adapter is because we need access to the master database, which they won't give us. So that's why I advise you not to go down that route. Full transparency, in Azure, we use Azure SQL DB. As and when that service comes to Azure Stack, oh yes, we'll make that available as a migration option as a default, because then everything's inside the one solution and it's off you go.
The way it is now, there's no Azure SQL DB on the stack.
No, the SQL PaaS offering is not Azure SQL DB, it is a SQL adapter. So what that does is that fronts SQL instances that you stand up and manage and maintain in IaaS. So we get past that, we need a UNC share, and then we get to the point where we need to do capacity topology. So let's actually go back to the deck and we'll go and have a look at what we end up with, and then we'll come back to the resource group at a later date. So can everybody see that at the back? Is that diagram detailed enough? We'll drill into it in the resource group, but just to give you a very high-level overview. So we deploy inside a resource group. Inside that resource group, we deploy inside a VNet. And inside that VNet, with the build that you will next get, you will start to see a lot of NSGs show up, and a lot of different subnets and a lot of different IP space that we actually run in. We are in the process of absolutely locking this down to the point that it's production ready. So the controllers, you'll see there that we don't deploy too many of them. We deploy 2. So the way that our controller resiliency works, it's in active passive. So it's active redundant. So the second controller will only ever come in once the first one fails. So for that reason, we never say, technically you can deploy as many as you want, but we only ever advise do 2, because it's a waste of resource. Why deploy more than you actually need? Then we deploy in VM scale sets, everything else. So our management servers, our publishers, front ends, workers are all in scale sets. Our management servers, our front ends, and our publishers sit behind SLBs, and then we have AOR on our front ends as well to front our requests and do that. The storage accounts are here because we're using VMs, so we heavily tie those, and we deploy all of the storage accounts that we need initially with all the scale sets. We go down at the bottom, those icons indicate the file server and the database because they're outside of our deployment. We don't deploy those, they are not part of our service, they're resources that we consume. That's analogous to what we do in Azure today. We use services within Azure. We create DNS entries within Azure Stack DNS, so we create DNS zones for our needs, and this is all deployed for you. So what happens when it goes wrong when you're deploying? What do you do? So your first step is the app service installer. The app service installer goes through every single step that we deploy. So be that we register a provider, we create a storage account, we download all of the packages we need, we put them into blob storage, etc. Then dive into the resource group. So the resource group can give you information at a low level of what's failed, whether it was a VM that failed to instantiate, whether it was a network resource that wasn't provisioned, etc. To be brutally frank, if the infrastructure comes up, we haven't even got as far as installing. So we need to troubleshoot right back to that level. It's the same as you provisioning a load of VMs. If that VM's not healthy and not available, we can't deploy something on top of it. So, there's Azure Stack logs to look at. So on each of the instances, we run what we call a custom script extension, and there are logs for those. So that's where we execute our packages, and we can investigate those logs to see what failed. Once we get past that, we can go into the App Service Resource Provider admin. So directly in the console, which I'll show you in the UX, we can see the logs of each role as they come up and what's happened and whether they've failed, whether there's been errors, etc. If for any reason that part's failed and we haven't got to the point that we've registered the resource provider, we have a backup plan in that we can remote onto the controller. You have to open up the NSG to do this because we don't, it's kind of like a crack the ice point of view. We don't enable it by default. And go on to our web cloud management console. So we have an MMC snap in onto the controller, which enables you to dig into the app service settings. If you've used Windows Azure Pack websites, you'll be very familiar with this tool. If you're not familiar with that tool, use it for now, but over time, those features will come into the portal and we will look to move away from that tool. We want to get to a stage like we are in Azure where there's very little need for you to actually remote onto any boxes. And today we allow you to do RDP, but once we get JIT access and that sort of thing, then we won't allow you to do RDP because we'll go through the JIT console. And then finally, there's event logs. So every single one of our roles pushes out ETW events. Again, this will come into the portal in time. We're working with the Azure Stack team to enable that so that can come into an interrogation service inside the portal and you can investigate that way. That is important for the service as a whole once you're up and running. So let's go into the portal and see this running. So let's close that because that's a waste of time. If you want to see, if you've got specific interest in the installer and the flow, I'll demo it on the floor later on because I can stand up a few other file servers so I can get past that block and we can try it. So from a base level to get to the information that I was talking about on the roles, all you need to do is drill into the individual role. So I've got a couple of web workers here that seem to be in a bit of a state. So I can see that they haven't actually been instantiated, so we've got an issue there. But if I go into, say, the controller, and then go into one of the controllers, I can view all of my logs and see the events as they're coming out. So I don't have, so let's change to info. Come on, I know there's messages there. Yeah, there you go. So I can see the information that's coming out, and we also have an ability to copy those out, and you can send them to us or interrogate them via whatever mechanism you want, you know, some simple as Notepad or whatever. But the guidance, the way that we're driving this is that your first entry point and your only entry point should be the portal. If you have to break glass, then we're in a situation where we have something, you know, there's the situation that we're not covering. So we don't really want to be in that situation. Just to dive back, this is the app service management. This is the console that we'll probably, as a team, spend the largest amount of resource on, is making sure that you've got the best tools possible to actually administer the service and be able to support your tenants and your users. The tenant features we just get as a value add because they're already in Azure, so all we've got to do is bring them down, enable them, and off we go to the races. So in here you can see the system properties, configuration, source control configuration, which we'll come to in a little while, details around credentials, the roles that we have running in the farm, IPSSL configuration, SKUs, pricing tiers, custom software, which is a nice value add that we have for app service on Azure Stack. So back to the deck, and then we'll come back and do worker tiers. So custom worker tiers, as I briefly touched on earlier, give admins the ability to deploy custom workloads, and they're a way of differentiating your offering. So you can, if you're an internal enterprise, you may have internal assemblies, and that may be the reason why you literally cannot move to Azure, because we don't allow you to install additional components onto our workers because we're a multi-tenant service. So you may have workloads that you literally cannot move into the public cloud. So we give you this ability to be able to deploy those onto your workers, and by creating a custom worker tier, you can segment those workers from your other offerings. So you could have very much a case of these workers are plain vanilla app service, but these ones are specific to a department that need a particular component or to a workload, and then off they go. So for example, deploy non-core application stacks, for example, Go, Ruby, or database connection connection components such as Oracle. So you've got a lot of Oracle interaction. Well, install the database connectivity tools onto those machines, and then when you deploy an app, you don't have to bin deploy all those different components, if they can be. Some components can't be deployed that way, so you do have issues. And there are ways of deploying those through a PowerShell script so that you can actually do the environment variables and that sort of thing that you need to do as part of the startup. In addition, custom SKUs. So as custom SKU, I can define my features and my quotas of my SKUs that I want to allow people to take advantage of. And yet again, this session is kind of pinned towards service providers and enterprises, but some things cross the boundaries and some things don't, which is why when I'm talking about it's another way of differentiating between the competitors, it's a way of differentiating between us, but also it gives you a way of doing different services for different teams and that sort of thing. And the SKUs are very much tied to worker tiers. The worker tiers come first and then the SKUs. So let's have a quick look at what that actually looks like, and then we'll come into capacity planning. So I'm going to go and create a new worker tier. And let's call it Orlando. And I'm going to do a dedicated. My stock size. So this is an indication of what the sizing is, whether it's small, large, medium, all the way up. So this is where you would get the numeric. So let's call it a 1. Compute image. Because we use scale sets, we will deploy a new scale set for every worker tier. So the base image that you use is important as to which you select. And then the VM size. You've got the full plethora of all the compute resource provider VMs that are available. This is what I was saying earlier. If you have hardware that exposes something that we don't, then why should we stop you? We give you the ability to integrate with CRP and decide which one you want to go for. So I'm just going to create a D1. And here's that option for custom software. If you have custom software in the system already, administered through the custom software blade, this is where we give you the option to pick and just add it onto those workers. Otherwise, you can actually add them this way as well. I'm not going to do that today. I just want to create my worker tier. So we go off and create the worker tier, and in the background, we're creating a VM scale set. We're getting it ready, but the VM scale set has no instances. So let's go and create a SKU. Let's add a new one. No. The stock size is purely for when we do, the SKU becomes a letter. So you'll be familiar in App Service where we have like an S1, S2, S3. The 1 is that indication. So it's mainly on size. It's about the only thing that if we could automate it so we could lock it so that we knew that that's a small instance, then that's possible. But we don't know at a worker tier level whether you decide that stock level 1 is a D3, but then stock level 2 is an A3. So how do we determine which one is like large and small? So we give you the control over that. Family, then this is the indication of the letter. So all SKUs and worker tiers are identified by a combination, by a letter and a number. The size is the number, and then this is the letter. By default, you cannot use F. By default, you cannot use D. And by default, you cannot use S, because they are reserved for us, because we deploy that way. So once they're gone, you can't use them. In recent builds, you could use Y, but that would end up with an error, because Y behind the scenes is what we use for a functions consumption plan. So please don't use Y. So today, what are we? Let's use O, because we're Orlando. I can choose the color card for my pricing, so when a tenant uses it, I can see what they're going to get. So let's go and use Orchid. I am working on how we get more colors in there, but they come from ARM. So let's go dedicated, and now I can choose the worker tiers that are dedicated. Come on. There we go. So there's that new one that I created. Now I can use Orlando. I dive into features, and this is where I can see what I want to enable, what I want to turn off, what capabilities I want to add, etc. By default, we let you do everything, and the same with the quotas. And here you get into the real nitty-gritty of what you allow your tenants to do, what their memory limits are, how many sites they can have, what their maximum execution can be before you start killing their process, etc., and what you do in that situation. So that goes in crates. That then becomes available in the pricing tier for your tenants. However, you will see a situation where the tenant would need to have it in their offer, in their plan and their offer to be able to use it. But also, if I create an app service plan, so I'm in the tenant portal now, systems that go cold. So that worker tier won't show up here, but what I want to show you is, you see the gray ones? They're marked as gray because there's no roles available for a customer to purchase to deploy onto. So in Azure, we deploy thousands of workers at a time. So this is not a use case that we had to hit. But in Azure Stack, there is a situation where you've got a limited resource that's available in your Azure Stack integrated system, right? Not only that, you as admins need to provision the scale. So if you haven't provisioned enough scale, you are going to hit a situation where a customer can't deploy. You don't want to have oversubscription because this is a dedicated resource. This is an allocation of resource. So this is two-way. You may start getting support calls. There's no available instances of X that I need. So then you know scale, but hopefully you never get those because you've already scaled up beforehand. But it's just so that you know what the customer experience is when that situation happens. And we'll come to scaling in a moment because we're going to deal in capacity planning now. So minimal viable production deployment is 2 controllers, 2 front ends, 2 management, 2 publishers, 2 shared workers, and then for every web worker dedicated that you have, for every worker tier, you should have a minimum of 2 workers. Now, if you're offering dedicated hosting of applications, you're going to have the bottom 2. That's the minimum. But in reality, you're going to have a lot more than that. We have hosters currently using our previous version of the product, talking 200 workers, 200, 250, 400 workers. As I've already said, we deploy 1,000 at a time. In every single stamp that we have 1,000. In theory, your limit is whatever your Azure Stack appliance can take. So if all you're interested in is app service on Azure Stack and you've got a 12 node, whatever the SKUs that you deploy as those dedicated instances, there you go. So we ship out the box S1, S2, S3, which is an A1, A2, and A3, which is exactly what we deploy in Azure. There's nothing to stop you just changing those to be D series, DV2 series, whatever. You pay the same price to us, we don't care. Question?
If we create a lot of workers beforehand, do we get charged or do we get charged when the customers stop using them?
Okay, so I was going to cover billing. I'll cover billing in a little while because it is an important question and I do need to go through it because I want to cover billing and the usage API in both the same talking point. But the key thing that I wanted to get across here is this is real. This is, if you are running this in production, don't think you get away with like 5 roles. We're not magic. We still need to do HA, we still need to do load balancing, we still need to be able to handle failures. So let's go and look at how we add capacity. And we've made this easier by using scale sets. The one rub today is with a controller. So my guidance with you is, if you want to have multiple controllers, and this is what I advise, so if you know you're doing a production deployment and you need multiple controllers, deploy 2 with the installer, because we'll take care of it. Otherwise, it's a very manual process because the controller is not deployed as a VM scale set. And that is very much a decision that we made on purpose because we never see the reality of using more than 2. So we don't get the benefit of scale sets, so let's just go VMs. Today, you go to roles, and you go to scale instances, and then you choose the type of role type, At the moment, if you want to do the other roles, do them through the VM scale set itself, and we take care of it in the back end. We just don't have the UI wired up for anything other than workers. Workers is our principal target initial, because that's the thing that you're going to need to scale up faster than anything else. So web workers, I can choose the tier, and I'm going to go and say, well, I want to scale out Orlando. So I can, you'll see from the slide, you're thinking, well, you can only do 5. No, you can put whatever you like in the text box. It's just we're only going to have, we've got small scale. So I'm going to do 2, and it gives you information about the SKU that we're on and what we're doing. So off we go. That is important because we need to register in our database what SKU you chose. Because then when we generate usage records, we know how many compute cores you're using. So that's where we scale. And you'll see immediately the VM scale set says, right, okay, that's scaled out, it's ready. But it's not. It takes about, depending on the hardware that you've got underneath you, it can take from 35 minutes to 90 minutes to deploy a worker. Because adding the VM to a scale set is easy. What takes the time is installing all the application stacks and everything else that we need to run. We recognize this as a challenge, and we are looking at what we can do about it. Because VM scale sets, you can swap out the OS image. That's one option. So we give you the ability every time we do an update to basically build a base image. So you come along, give us Windows Server, fully patched. We deploy everything. Then we go, there you go, there's your VHD. Go and upload that, and that's what we use. So we're looking at that as an option. We're looking all the time at how we can speed this up. In Azure, we use cloud services. So doing updates is like, it doesn't take us anywhere near as long as it does in IaaS. Same with Windows Update. I'm going to deal with that question whether I've got a slide or not. App Service can orchestrate Windows Update. We did that in RC1, and we got a load of feedback. This is taking too long to install. Please stop it. So we took the capability out by default. But there is no reason why you can't enable it on the controller for us to take care of patching. But the challenge is, when a patch comes out, we only take like required security updates. But when a patch comes out, you end up waiting a long time for those workers to be ready. So we're kind of looking at something that we can do a bit more, that's a bit less abrasive. Because the thing that we hit with RC1 was we released on the Monday. On the Tuesday, Microsoft Update came out with a 1.5 gig update. So suddenly our workers were sat there waiting to download that and update because the Azure Stack image that we were using from Marketplace didn't have those updates in. As soon as we updated that Marketplace image, then off we go, we were back to the races. Just, full disclosure, I'm not here to hide things from you. I'm here to tell you the truth. And that's something that we hit, and that's something that you're going to hit. So the adding capacity is as simple as that. You add a couple of clicks, and then we go off and we do the deployment. They will suddenly become ready, and then that's when your users can make use of them. It's the first task for most afterwards, and please add them through the admin experience. The controller basically registers, so when the VM comes up, the VM says to the controller, here I am, register me in the farm, and the controller then says, right, here's a load of work you need to do. When you come back and tell me you're ready, that's when I'll put you into rotation. Configuration of deployment sources. So this is important, and I've had some questions of why do I need to do this as an admin? And the reason you need to do this as an admin is because in Azure, we are the service. We run it. We've said to GitHub, to Dropbox, to Bitbucket, whatever, we want the access via an OAuth token to be able to take the user's details, authenticate with you, and then pull in their repos. However, this is your deployment. This is your endpoints. This is your domains, everything. We don't know the configuration of where you're going to deploy this, so we can't do this for you up front. So what you have to do is you basically have to go follow a few steps to do an integration with, say, GitHub, give them the reply URL, what the service is, what rights you need. It's all documented. And then they give you an application ID and a secret. You plug that into the resource provider inside the, in the blade. And one thing that we've done to improve there is previous version, you had to repair the management roles to do that. You don't need to repair the management roles anymore. As soon as you enter that, it's available. And then when a tenant goes into the user portal, they would then see those options light up. But analogous to the app service plans, if you as an admin haven't lit those up, those options are grayed out. So you can end up with questions, I want to use GitHub, why won't it work for me? It's grayed out. You know straight away it's because it's not actually been set up. But that therefore gives you the control as the admins to say what people can and what they can't use. On top of that, if there are source control providers that you have, or repository providers that you have in enterprise that you would like to see in this, they would likely come to Azure Stack because that's where we're looking at the vector, not into the public cloud. But I am very interested in hearing what they are. Because we've done Git, we've done remote repository, we're working with TFS, we do Dropbox, we do OneDrive, but there's probably others that you want to be able to automate direct pull from. So please give me that feedback if possible. I've got 8 minutes, okay. HA, App Service on Azure Stack. Sorry, I'm stood here talking to this. High availability. So App Service on Azure Stack is not HA. And the reason for this, and Azure Stack have been quite open about it, Azure Stack only deploys a single fault domain. So therefore, by the way that they balance VMs, I cannot guarantee that if you've got 2 management servers, that they are not going to end up on the same node. And if that node goes down, you're gone. And that's, again, full disclosure. That's why we cannot certify as HA. In Azure, we use fault domains heavily, and we need to in terms of doing that in Azure Stack. So therefore, until that comes to the product, which I believe is coming, they're working on it now, but we don't have the specific date of when that's coming, then we cannot say that App Service is HA on Azure Stack. The requirements in order for you to support high availability so that you can start to plan it when you do come to that point is that you must have multiple instances of roles for resilience and performance, maximum of 2 controllers. Your management servers, because they are doing so much work with the UI and the API, don't scrimp on them. Make sure that they're deployed on decent SKUs and that you've got multiple of them to handle whatever load you're going to have going through them. And you can already make use of existing infrastructure in terms of your SQL Server cluster and your file server. If you don't have infrastructure there, you can deploy those workloads in the default provider subscription, and that is, according to the licensing team, that's fine. They will be zeroed out. You won't be charged for them. Billing and usage of App Service. So Azure App Service on Azure Stack, in order to offer free and shared, you need shared workers. If you decide that you don't want to offer a free and shared SKU, you don't need shared workers. However, if you want to offer, so Azure Functions can be deployed in two tenants can use Azure Functions in 2 ways. Because it's serverless, they abstract it away, but you need to care about it. They can deploy functions in the traditional app service plan model. So if they've already got sites in an app service plan, they can deploy their function workloads in there and take advantage of just paying 1 bill. However, Azure Functions is designed that we give you high execution, but we don't charge you a lot of money. So the idea is that in the public cloud, we use spare resource. In Azure Stack, there's no such thing. So you need to provision resource. So the best way that we could come up with doing it is putting it on shared workers because they're multi-tenant. There's probably some spare capacity in those, so we're okay. And for the consumption plan, you need to have shared workers. So if you want to enable customers to run functions and then charge them based on executions and based on memory usage, then you need to have consumption plan offerings, so you need shared workers. And shared workers are metered as soon as they become ready. So if you, and this is important for you guys, because if you have 10 shared workers and they are all ready, we are ticking the meter and sending the usage back to Microsoft so we can pay you, we charge you for them. So we charge you for the workers as soon as they become ready, and we charge you based on cores per month, I think it is overall, is the charge. But we do that incrementally, so if it fluctuates over the month, then you'll get a realistic bill. The dedicated workers are slightly different. So dedicated workers, the same way as we do in Azure, we don't charge tenants for these until they're actually in use. We don't charge you for those until they become marked as ready and an application is deployed on them. So you could have a farm of 200 dedicated workers sitting there waiting to be used, but only 10 of them are actually in use by an app service plan from a tenant. You would only pay for those 10 while they're in use. This way you can have the availability and the high scale, but you've not necessarily got the large bill until you're actually using it. So that's the way that we build. Usage output, you will see app service plan hours for web, API, and function apps, and then you will also see compute duration measured in units of gigabits per second, and compute requests measured in units of 10 requests. So an example of that, I don't have the function, the PowerShell running, but one of my devs sent me this at the weekend because he'd been working on it. And this is the kind of output that you will see inside the PowerShell script and in the API that you can query the usage service. We were not aware in previous builds that we were intended to output our usage into the usage service. So I spoke to customers at a Hackfest, and they were like, we can't build for app service, we can't build for functions. I'm like, yeah, you can, it's in our metering database, you just need to do X, Y, and Z. No, we need to use this. Okay, right, leave it with me. So in the next release, there will be usage information. There's not in the current public release, but there you go. Based on the way that we build for functions, you are going to have to generate a significant amount of load to see those meters really start triggering. Because I think in Azure, we give customers 1 million executions a month before we start billing. So serverless is not a high revenue offering. It's a fantastic service, and it's a fantastic programming model, and it enables teams to do some awesome stuff, but it's just a caveat there. You're going to make your money on your apps, your API apps, your mobile apps, and then functions is your value add. But, you know, having a serverless offering in the world nowadays is very, very valuable. So in review, today I've covered at breakneck speed deployment experience, the capabilities in our admin resource provider. There's some others there that I haven't even covered, though. The ability to configure the IPSSL, the block list at our level, so we enable that capability. And then there are more sessions. Why haven't I filled? Whoops. I have got a slide in oh no, I've got it next. If you've got feedback on Azure Stack, please go and participate in their research panel. They feed it back to me, and I feed back to them. I meet the Azure Stack team probably 3 or 4 times a week, and we work very, very closely to enable, because we enable them and they enable us, and vice versa. It's very much a two-way path, so it's very, very important. Related content, there is more information there. So integration into your data center and updating and servicing Azure Stack is probably very relevant to this audience. And we're only about 1/3 of the way through, and we've still got lots more content this week. I have 1 minute for Q&A, but as I said, I am going to be on the booth this afternoon. So I'll take a few questions now because I didn't have time in my previous session. So any questions from the floor?
So just like I might have missed the beginning, these VMs are in tenants?
No. So these are the service. They're in the default provider subscription. All VMs for App Service are in the default provider subscription. As far as the tenant's concerned, the tenant is concerned about their application. They're not concerned about the infrastructure that it's running on. That's what the admin's concerned with. Okay? Thank you very much.